5.2 mean value theorem. So this is going to look familiar. Mean value theorem for derivatives, because how is this different than what we've done already? It's not. We said, hey, let's make a definition of a derivative. We have some curve, we have some points, and we keep bringing those points closer and closer together until we find the tangent curve right there. Well, the mean value theorem sort of turns us around. It says, well, if you give me a point A and a point B, and there's no H, we're not minimizing it, just whatever. And then you get your point B comma F of B, and your point A comma F of A. Hey, if it's continuous and it's smooth, then you're going to be able to find at least one point that matches. Heck, you may even be able to find more than that. Let's take sine and say, hey, we're going to use this point and this point. You say, okay, the slope of that is that. It's continuous to smooth. Where else? Well, here, here, here. I mean, you got all sorts of things going on there. So it's an existence theorem. Learn how to calculate things. It's really bothers people. Like, how am I going to use this? I'm just going to say you have to find where it happens, right? And I'm actually using almost exactly the diagram on the left that we just used. It tells us this is going to happen. And for whatever reason, I think because it ties back in with the definition of the derivative, it's a really, really favorite question in AP calculus. They love it. So we say, hey, what's going on from 0 to 2 in f of x equals x squared? This is 0, 0. This is 2, 4. Where is there going to be a point that has the same slope? Well, okay, 2x, that's the derivative part. Notice we don't know where x is, equals 4 minus 0 over 2 minus 0. This is the f of b minus f of a over b minus a part. 2x equals 2, x equals 1. This point is at 1. That's it. All right. C equals 1 is your solution. That's it. There's nothing else to say. A lot of people, well, what does that mean? Doesn't mean anything. Just the spot exists and move on. Once again, though, it's very, 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 very popular among AP calculus problems. So don't forget the definition. Why do these fail? All right. Well, over -1 to 1, square root of x squared plus 1 is actually just like absolute value. This is just like saying what's the absolute value of x plus 1. And we know that's going to go here. 1, -1. I drew arrows, but let's make them points. Okay. So why does this fail? Because it's not differentiable at 0. It's got a corner. So if we were to try to mean value theorem from -1 to 1, we'd say, okay, there has to be somewhere where the slope equals 0, because that's what we get when we plug in 1, 2, -1, 2. So this point is 1, 2, and this point is -1, 2. Well, if we found the slope, we'd get 2 minus 2 is 0 over -2. Slope is 0. Well, there is nowhere else on this curve, right? It's not differentiable. Might there be a spot? Yes, but in this case, at 0, we needed it. So, no. So here we got x is less than 1. Plug in 1, we get 4. So we've got a hole here, and it's up there at 3, something like this. And then x squared plus 1. 1 plus 1 is 2, and that's a solid hole. It's x squared, so it's doing this. All right, so is it continuous? At x equals 1. So what? I mean, hey, I can't find some spot here. There's no point to work with here because it jumps. It's not, if I do this, there may or may not be a derivative that goes. It could happen, but we don't know because they didn't give us a continuous function. So it's not guaranteed to happen. So let's try another one. F of x is this, a equals that point, b equals that point. Find a tangent that's parallel to the secant. So let's go on a little aside here. F of x equals square root of 1 minus x squared. Y equals square root of 1 minus x squared. Y squared equals 1 minus x squared. X squared plus y squared equals 1. Hey, I know that. That's a circle. Kinda. There's no plus or minus up here. So it's upper half of a circle. And you might say, well, I didn't recognize that. Well, yeah, I mean, that's why I'm the math teacher. I do this for a living. So radius of 1 does this. All right, it says from -1 to 1, find a tangent that's parallel. So it says basically do the mean value theorem. So when I plug in 1, I get 0, and that makes sense. 1 comma 0, and -1, I get 0. And it looks like it's going to be right there. But let's do a little calculus. So f of x, yeah, by the way, this is a slope equals 0. F of x equals 1 minus x squared to the 1/2. F prime of x equals 1 over 2 times 1 minus x squared to the 1/2 times -2x. Don't care about the bottom. I care about the top. So when does -x equals 0? When x equals 0. So there it is. This is 0 comma 1 or whatever, but it's at 0. That's where it happens. We've answered the question. Where can we find a parallel line at x equals 0? What's the slope? Nobody asked, but obviously they're both 0. What's the equation of line? Nobody asked. That's y equals 1. That's where it happened, and that means typically on the x. So I don't think the mean value theorem looks like much, but now they say, well, this means we can talk about properties, whatever. So interval I, it's a function defined on that. It increases, yada, yada. I mean, this is silly. We just look at it and know where the slope is up and the slope is down. So x squared we would say, well, let's y prime equals 2x, 2x equals 0, x equals 0. Plug in 1 and I get a positive. Plug in -1, I get a negative. So decreasing, x is less than 0. There's a whole big argument where they'll say it's less than or equal to 0. I don't buy it. I don't buy it. But you would not be shocked to see that the answer written as either this or this. It never pops up on the AP test, and we certainly don't have any complaints about it. Just be aware. And over here, increasing because the slope is positive. X is greater than 0. Again, 0 to infinity, or you might see it as 0 to infinity. The reason that it's blocked off, I believe, is that I can always find any number smaller. You say, what about 1/10? I say, what about 100th? You say, what about 1/1000th? I say, what about 1/10,000th? Therefore, they say the limit gets closer and closer to 0. I don't buy it. I'm not getting into it. Don't lose any sleep over it. So where's the function increasing or decreasing? Same thing as the previous lesson we did. F prime of x equals 3x squared minus 4. 3x squared minus 4 equals 0. X squared equals 4/3. X equals plus or minus 2√3 equals plus or minus, sorry, I'm a math geek and I can't write it that way. Even though on one of my homework problems, I wrote it as √2/3. This one, if I can take square root, I gotta rationalize it. It's just, sorry, who I am. So here's the problem. -2√3/3, 2√3/3. Kind of need to know about what this is. √3 is 1.7. 2/1.7 is a little bit bigger than 1. So this is like 1.1, 1.2, something like that. If I were really in a tight spot and had to find a value between, I'd have to bust out my calculator. But I know zeros between them. So 0, plug it in, I get negative, decreasing. A gazillion goes in here and I get a monster huge positive number, and the same thing over here because the negative gazillion is squaring it away, so on and so on. So we would say it's increasing (-infinity) to (-2√3/3). I'm going to put a parenthesis again. I've seen it done, but that's a bracket. And also, look at me talking out loud, 2√3/3, comma infinity. And then it's decreasing from, this is why I don't like the bracket, because then it's increasing and decreasing at the same spot. Yeah, whatever. (-2√3/3, comma 2√3/3. So a little bit more ticky-tack stuff. I mean, that's really where we're going with this, is making sure we're clear about it. So a corollary, where if the derivative equals 0, then there's a constant for which the function equals c for all x in that interval. Sorry, I nearly didn't get that there. Yeah, duh. I don't know where to go with that. I mean, if the derivative equals 0, then we have f of x equals a constant like 12. F prime of x equals 0. Like, wait a minute, this feels like they're getting into what I would call an antiderivative. So they're kind of leading you to, hey, if you know the derivative is 0, and you can go backwards to some constant c. We don't know what the constant would be. It could be 10, 12, 3,000, whatever. Okay, it feels like they're thinking about touching on that. The same thing here. If the derivative is the derivative, then they're going to be parallel, plus or minus some constant. Interesting. F of x equals g of x plus some constant. Think about it. I take the derivative, that constant up and vanishes. Okay, so it feels like they're getting into antiderivatives, which is just going backwards. Take a derivative, put the number out front. Now we would add 1 and divide by it. You'll see when we get there. So find the function's derivative sine of x whose graph passes through point 0, 2. Well, I happen to know that if we go with f prime of x equals sine of x, then the function, and we actually would usually capitalize this to indicate that we're doing something else, negative cosine of x. Yeah, but it might have some constant there. We don't know. We don't know. But we do know that it passed through 0, 2. So we do this thing, 2 equals negative cosine times 0 plus c. And that's -1, add 1 to both sides, c equals 3. So the function is negative cosine of x plus 3. So we're getting into what we call antiderivatives. How do we go backwards? Right? Oh, check it out, capital letter. So I really should have put this as f of x, indicating that I was given a derivative and I'm finding the antiderivative. No, actually, that's not true. That's not true at all. Leave this as your f of x. Leave this as your f of x. We only use it when we say, hey, we have an f of x. Let's go to the antiderivative. Then we go with a capital one, indicating we're going backwards. All right. So told you we're getting there. Antiderivatives. It's really just common sense. There's nothing complicated here. How did I know? I know that derivative of cosine is sine, negative sine, so derivative negative cosine is sine. Just roll with it. Not a big deal. And then that leads us into going backwards on the velocity and position functions. All right. So given that the acceleration 9.8, throwing out my units because they get in the way. It's falling, so we're going to go with a negative. This really should be a negative, but whatever. Well, then find me the velocity, negative 9.8 t. Well, how did you know that? Well, what's the derivative of that? Okay, and then like we said, there's some constant. Well, I happen to know that the velocity falls from rest. Velocity at time 0 equals 0. So 0 equals negative 9.8 times 0 plus c. C equals 0. So my velocity is negative 9.8 t. Turns out that constant, which I didn't know, is 0. How about the position function? Well, now we do the whole thing in. S of t equals, here's how you do an antiderivative. And the way I do it is guess, and then I check. We add 1, there's an invisible 1 here, 2, and divide by it. Negative 4.9 t squared. Whoa, whoa, whoa. Check. 2 times this, 1 works. Plus some c. Now, falling from a height of 0 meters, so we must be looking over a cannon or something, a canyon or something. So that means that s of 0 equals 0. Run a little out of space, so let's throw it up here. S of 0 equals negative 4.90 squared plus c. And this can get confusing with these c's, so let's go with c1 and c2. So we know what we're talking about. C for constant, often a k in calculus for the German constant. So c2 equals 0. So the position vector is 4.9 t squared. Okay. What if it's not starting from rest? So going to do a little shortcut in here. If t equals negative 9.8, we really should throw units on this and the velocity, but I'm lazy. So now we've done this. V of t equals negative 9.8 t plus some constant. Initial velocity is 1. So I'm standing over a hole in the ground and I throw it up the velocity of 1. Well, check. This initial velocity means v of 0 equals 1. So if I plug in 0, cancels, and I'm left with 1. V of 0. Good, that works. And then s of t equals negative 4.9 t squared. How did we? Yeah, we already saw that. Plus t, integrate that. Derivative of t is 1. Plus some constant. Well, I already did the thing is 0. So I know I'm done because S naught of 0 is 0. Let's check it out. Plug in 0. Like I said, I'm shortcutting 0, 0. I get 0. Check. So just introduced you into what's called integrals. We start by calling it an antiderivative, meaning we just do the opposite of a derivative. And look at that. We guess and check. Works. Add 1, divide by that number is the way I do it, but yeah, different strokes for different folks. Good luck and happy mathing.